Alright. Hello once again. So this sessions I am taking on functions. See, ideally functions are the core of the language. Up till now we have been coding some tidbits here and there, but we are not really looking at the systematic arrangement of our code. We're just putting code in main. Okay, now in your practical life, you would not really be wanting to just write the code, maybe just 4 lines of code. Ideally, you would want a big chunk of code. A lot of functionality is required in your day-to-day lives. So you can't really just go about meaning just put in 4 lines of code and execute those lines and it's done. No, it's not that way. Our lives are complicated. And another thing is, first of all, so you can say the first reason is your code will be lots and lots of code. Okay, so you need a way to manage this code. Secondly, you would want the same code all again and again, multiple times. So there is no way by which you can recall the code right now. So how do we go about this? First is managing our code. Second is we should be able to recall this code again and again. So if I want, let's say, to calculate a sum of two numbers, now the sum or average or total or gross or whatever, these calculations are required at multiple places by me. So do I copy and paste the code again and again? No, that's not an ideal scenario. So ideal scenario would be one wherein the code is available at a single call. Okay, since we are working with systems, things should be automatic, things should be simple, and we should not be. It should not be a manual workload too much on you. So we have something called as functions. So let's delve into the session. I was ideally trying to get the session working on Visa. All right. So this is about the function. What is a function? Ideally, it is a sequence of statements designed to do a particular job. Okay, so we are making a chunk of statements. So ideally, whatever you have been writing till now, the code will still be the same. There's ideally no change in the code, meaning whatever task you're planning to do, you'll be doing in same if statements and same calculation stuff. But now all that will be enclosed in a block. Okay, and that block is ideally called a function, and that block will have a name to it so that we can recall the block again and again via that name. So that is in simple terms a function. A sequence of statements which are designed to do a particular job, you're putting that in a block. Okay, and ideally that the name that you plan to give to your function is depending upon that particular job that these set of statements are doing. So if the statements are doing, let's say, calculate gross salary, you can say calculate gross as the name of the function. Okay, so coming back to the slide here, a program will be executing statements sequentially inside one function when it encounters a function call. So you can make your program go to a particular function by just making a call to that particular function. So what is a function call? It is an expression which tells the CPU to interrupt the current function and execute another function. So it's like a bookmark. In your book, you have a bookmark whereby, let's say, if you want to get the reference of a particular thing which you don't understand, which is probably some pages ahead, you just move from this position to that some pages ahead position. Okay, and once you are finished reading that particular part, you come back to your current position. That is the same here. The CPU is putting a bookmark. So this is happening internally for you. It is putting a bookmark at the place of current execution, and from this particular point it's jumping to the function call. So executing a set of statements specified there, and once that function finishes execution, we come back to the current bookmark. Alright, so function named in the it executes the function named in the function call, and when the called function terminates, the CPU goes back to the point it bookmarked and resumes execution. So that is how it works. There's an example which makes things clearer. Always examples do the job. So we're taking an example here. So here this is the function. We have declared a function as do print. That is the name. So see, your functions, ideally if you look at the best practice for naming a function is a verb which indicates what the function is doing and the task that you're supposed to do. So a verb and a task. So do print is a name. And void part, we will just take up this part. So as of now, just leave this. So focus on the name. Do print is the name of the function. This is how you write a function. A open bracket and a close bracket and a block of statements indicating the opening and the closing. Okay, begin and the end. So at the moment, this function is typically doing nothing but just doing a print on the screen. So cout in do print is what will be displayed on the screen. And using namespace is there because we're using cout and endl. Ideally, we will come to the using namespace also. So at the moment, just focus on this particular part, cout. So you can say the function is just a single line function which is just printing something on the screen. And the moment it finishes printing, it comes back to the calling function, the function which called it. Calling function, the function which called it. So it will come back to main. So this is how the program execution works. So if you see right now, apart from your main function, so now you know the main is also your a function only, but it is having a predefined meaning in the compiler that it is a entry and exit point of your program. Main is defined to be there in a program, otherwise your program will not function. Okay, so similar to, so main is one function which has been predefined, but doprint is one function which has been defined by us, and this blueprint is defined above main. Okay, so it's like an independent block of its own. So what happens is, again, when you write this program in main, you have cout and another cout which displays this on the screen. Then this is a call to the function. This is how you call the function. It's just a name of the function that you write with a semicolon. This is called function call. So if the function name is doprint, you just write doprint, the parenthesis and a semicolon. So this indicates that it will now jump to doprint from this point onwards. Okay, so it will display starting main. Since main is the entry point, the compiler will enter main, display starting main on the screen. Doprint is encountered, it jumps to doprint, displays in doprint, encounters a closing block, comes back to main at this point, and resumes execution from this point onwards, the next line, which is ending main. So display ending main and encounter a closing block, and the program finishes execution. And this is what is displayed on the screen. Starting main, in doprint, and ending main. Alright, so that is a simple function, definition and function call. Okay, so if you see here, functions can, if you see here, this is the function, this is called the declaration of the function and definition also. So we are in this three set of statements, we are defining our function doprint, whereas in this statement we are calling the function doprint. Okay, so it's good. Technically, these are called function declaration and definition and function call. Okay, coming back to this slide. Now, functions can be called multiple times. Again, that is another reason why functions are good for your program, generally required for your program. So, if had it been that you wanted to display multiple times that particular statement, you could have just given a call to doprint like this, and it will execute the statements defined in doprint again and again. Okay. And now coming back to return values. If you remember, when main finishes executing, it returns a value back to the operating system by using a return statement. So you generally see whenever we write main, in the end we have return 0. So what is this return ideally? This return is basically telling the compiler to return the control back to the calling function, okay, or return a value back to the calling function. So if you have a value along with return, you are returning that value back to the calling function. If you don't have a value, then you just return the control back to the calling function. And in case of main, there is no calling function, so ideally the program terminates with a return statement. Okay, so functions you write can return a single value to their caller as well. We do this by changing the return type of the function in the function's declaration. Okay, so when you're declaring your function, you have to specify whether your function is returning something, and if it is returning something, what type is it returning? Is it returning a int? Is it returning a char? Is it returning a float? Okay, and if your function is not returning anything, then also you have to specify to the compiler that it's not returning anything. And to specify that, you make use of the void keyword. Okay, so when you say void, the function basically returns nothing. So here's an example: void return nothing function, and when it does return nothing, then you use void. And when you suppose you want to return a number or integer, you specify int before the function name. So while declaring the function, you specify int. Okay. Similarly, had it been a decimal value, you could have written float return something. Had it been a decimal value, you could have said decimal return something. That way. Had it been a character, you could have said char return something. So that is how it is. Okay. So some set of statements to indicate what is the correct uh, cout for the compiler. So when I say cout return 5, this will print 5 because it will, this is returning int and cout is displaying that return value. When I say return 5 plus 2, it prints 7 because 5 is returned and plus 2. And when I say cout return nothing, this will give me an error because return nothing is not returning anything. Then cout will say, when I don't have anything, how do I display it? So the compiler will give an error in the last statement, saying that there is nothing for me to display. Okay, because it is a void function. Alright, so you can call. So here, if you see in these statements, in these three statements, the functions basically are called along with the cout statement. So even this is possible. The function call can be clubbed together. Okay, so in turn, this will be working on the return value rather than the function itself. It will call the function, do the job, and cout will work only on the return value. Okay. Okay, coming back to main, what is main? When the program is executed, the operating system makes a function call to main. Execution then jumps to the top of main. The statements in main are executed sequentially. Finally, main returns an integer value, usually 0, back to the operating system. Generally, when you say return 0 in a main, you're basically telling the operating system that main returned without any errors. Okay, that means main's execution was successful. You're telling it to the operating system. And sometimes if your main is buggy, there's some problem, there's some error while execution, so then we can even say return -5. So this way the compiler will come to know whether main was successful or not. So ideally your main is int main, so that we can return a value of 0 or 1 to indicate a successful execution or a error prone execution. Some compilers will tell you get away with declaring main as void. So you can even declare your main as void. Okay, uh, meaning void main, the compiler will not give you any error. But technically this is not good because we should have a way to find out whether main was successful or not. So it makes sense that you declare your main as an int main rather than a void main. Okay, so ideally we should be declaring our main functions as int, and return 0 is to indicate that our function was just successful. Similarly, you can put an if block in your main. So on the basis of certain execution where you want to display a success, you want to pass on a success value or a failure value. So you can have an if based on the condition, whatever condition is there. And if the condition was successful, you can say return 0, else you can say return -1 for an error. Okay, so that way the compiler, that way you can use this int as a return value in main. Okay, maybe that's at an advanced level, and for a basic level we generally keep it to return 0. Okay. Okay. So typically a function has three things to it. It has a function name, return value, and it also has parameters. Okay. Now coming to the parameters part in a function. A function can return a value back to the caller, right? That is via the return value. And what are parameters then? Parameters are used to allow the caller to pass information to a function. Okay. So let's say if the calling function wants to call the function with some information. Okay. It wants to call the function, it wants the function to display the name. and the name is what is supposed to be given by this calling function to the called function. So then this name will be packed in as a parameter to the called function. Okay. So this allows functions to be written to perform generic tasks without having to worry about specific values used, and leaves the exact value of the variables up to the caller. So again, we'll take it with examples so that you are more clearer on this. Now let's say we have a function add, or rather, let's say we have a problem. The problem at hand is to find out the sum of numbers. Okay, the sum of numbers is the problem at hand. So what do? We take in the numbers maybe, or the numbers are either fixed or the input is coming from the user. Okay, so what we can do is we can probably write two functions. Okay, maybe not in this case. In this case, ideally, we are just picking up two fixed values from main. Okay, in from main, we are picking up two fixed values, 4 and 5, and we are passing that to add function. So if you see, add function is declared here as two integer parameters, int x and int y. This is how you define parameters in your parenthesis. Okay, so in your parenthesis you define two parameters, and you also specify the data type, whether they are int, they are float, they are char, or what. Okay, separated by commas, and opening block, whatever set of statements you're planning to write in that, and a closing block. So our add is just doing the x plus y. So we could have done two statements. We could have declared a variable as int sum is equal to x plus y. Then we could have said return sum. That is three set of statements. Or since it's a simple task that we're doing it in one single statement. Since our function is supposed to return an int, we don't really need to declare an integer variable. So we can simply say return x plus y. So whatever is the addition of two numbers, that will be returned, since we have defined it as a return int type. So we are saying int add, that means add can return an integer value. So we are simply saying return x plus y. So what happens is when you say cout add 4 comma 5, the control is given to add here, and x gets the number 4, y gets the number 5, and we get a return 4 plus 5, that is 9. So that is displayed on the screen with this cout statement. And a return 0 makes the program complete and your program finishes execution. So that is how we pass in parameters to our function. There are some more examples here. Add, multiply, and in main how they are called. So now if you see, we can call add with multiple parameters. So the same function will get different results based on the parameters. That is the beauty of functions. They can be used over and over again with different set of input. So that is the reason why we are not taking the input in the function. We could have just taken the input in the function here with a cin statement, cin, enter x, enter y. But that could also be possible. Or you can ideally, in an ideal scenario, keep your functions specialized functions. Your functions are doing only specialized jobs. So have a function which takes input, probably in this case the input is fixed, it's coming from main. What if the input is required from the user? You could have probably taken the input from the user here in main, cin, enter x, enter y, and then call add, again cin, enter x, enter y, and then call add, that way. Or you can have a input coming in from main directly like this. So make your function specialized. Don't let your function do the job of taking input also, doing the job also, and then printing also. Then it's not callable. It's not really reusable rather. So if you want your functions to be truly reusable, just assign them a particular task at a time. Okay, so that you can use them, you can call them in multiple scenarios. If the same function is doing 3-4 jobs, they will not fit in all scenarios. So that is just to add on to this particular example. So another example is a and b. Like this also you can call a function with a and b as parameters passed in directly. You can pass variables as parameters, you can pass direct values, whatever. You can even pass another function as a parameter. So if you see, we are calling add here with 1 as first parameter, and the second parameter is coming from the multiply function. So what will happen in this case is, first there will be a call to multiply, okay, with 2, 3 as parameter. We go to multiply, multiply 2, 3, 6, return. Whatever is the return of multiply becomes the parameter of add, the second parameter of add. So 6 is replaced in case of multiply here, and that is passed as a second parameter to add, and add now is being called with 1 and 6 as x and y, and we get 7. So this will be displaying 7 on the screen. So this is a, example with multiple scenarios. Okay. So a slide which tells you why functions, how to best use them. Okay, so best practices. Functions offer a great way, okay, manageable and reusable paths, and they can be easily connected together to perform a larger and more complex task. Okay, and by breaking your program into smaller parts, the overall complexity of the program is reduced, which makes the program both easier to write and to modify. Okay, and so typically when learning C++, you will write a lot of programs that involve 3 subtasks generally. So in a any simple program in C++, these 3 things would be required. Input will be required, some calculation will be required, or some display of the calculated value will be required. So what you can do is, for simple programs, reading inputs from the user can generally be done in main. So input can be handled in main itself, and step number 2 is a great candidate for function. So calculations can be done in a function because they might be required again and again. And this function should take the user inputs as parameter and return the calculated value. And then the calculated value can be either printed directly in main, or again, for displaying the value also you can write a separate function. Okay. So if it's complex, the display is complex, you want to put in some multiple parameters for display, then it makes sense to write that also as a separate function. Okay. And the third rule of thumb is, each function should perform one and only one task for them to be truly reusable. Okay. So we have a small quiz here. What's wrong with this program fragment? Multiply, return xy, cout multiply 4, 5, return 0. Yes, probably you can pause the program here. You can pause the recording here, guess for the output, and then resume back so that you can just tally your answer. So I'll just tell you the answer here. The answer is return C. Ideally, you are saying a Cout of multiply 4, 5, but multiply has been defined as void. Okay, so for a Cout to work, you should return something to the calling function. Since it's not returning anything and it's a void function, my compiler will complain and Cout will not really work here. So at this point, the compiler will get a compiler error. In fact, at this point itself, we cannot really return any value because it's a void function. Okay, so for this program to work correctly, you have to change your multiply to a int as a return type rather than void. The next program, what is the problem here? The problem here is, again, please pause and just think about the answer and then resume. Okay. The problem here is, ideally, see, we have the return type intact properly. We have a product. What we are doing is we are doing the multiplication in a variable called as int product. Okay, and in main we are saying cout multiply 4, 5. But multiply is not returning any value. Even though the product has been calculated, where is the return statement? For the calculated value to be returned back to the calling function for any further manipulation or display, a return statement is required. So here return product will make the program complete without errors. So we need to add one more line here as return product. Okay, and then this will work just fine. So we have another set of problems here. Int add return x plus y plus z. In multiply we are saying return xy, and in main we are saying cout multiply add 1, 2, 3, 4. So first multiply will be called. Okay. And then inner calling add. So first add will be called because it will go from inner to outer path. First add will be called with 1, 2, 3 as parameter, and add will return these three added together as 3, 3, 6. Okay, so 6 is what we get here, and then multiply is called with 6 comma 4, and multiply is saying x into y, that is 24. So here the problem question is, what value does the following program print? So ideally it prints 24 here. And then there are two programs for you to complete. I hope you'll be able to do this uh, as an assignment for this class. And this as an assignment should cover your previous classes on C++ operators, conditional statements, and even loops. Okay, and then maybe you can just try and execute your programs. Then there are some more set of statements. I would really like to get output from you guys on these set of statements in the form of emails, if possible, and if not possible, maybe you can even put your queries to me, and you can just mark to me at trujyoti@yahoo.com. Okay, so looking forward to hear from you, and we'll continue the session in the next class. Okay, thank you guys. Thank you for watching this session, and I hope you are able to write good programs after this session. So any feedback would really be appreciated. Thanks a lot.